Okay, good morning. So if you remember, we started talking about the division algorithm. So hopefully you remember the content. What was the content? The content was that if I have, let me write it with a different color here. So if we have A and B integers, and if B is not equal to 0, then there exists a Q and R in Z. By the way, let me also tell you that if you have an exclamation mark here in front, this means that there exists a unique. Yes? There exists a unique. So this exclamation infer that this is a unique. So there exists a unique Q and a unique R in Z such that, you remember, A was equal to BQ plus R, but more importantly, R lies somewhere between 0 and up to, at most, not at most, less than absolute value of B. So that was the content of the division algorithm if you want to write it in mathematical symbols. And then we solved some very elementary exercises. I want to start thinking about these problems so that I can continue writing, and then we come back and solve these problems, and then we will finish this division algorithm. We go to the next topic. If not today, we will talk it on Thursday. Let's see what happens, okay? These are some a little bit harder questions related to this division algorithm. Yes. So I will continue writing one or two more, but you can start thinking about these problems. Thank you. Okay, these are examples, but I think many of you missed the quizzes. You have started actually not solving the quizzes. Try to solve them, okay? So only I think one of them submitted the last quiz in Math 5. So I just remind you, I will leave it open. I will put the deadlines, but I will not close the exams, okay, in case you want to manage your time in the future. But it is really good to pay attention to the deadlines, otherwise you have a lot of quizzes at the end which you haven't solved, okay? Let me solve one of them for you first. Might be you have forgotten some of these, so let me solve this one and then wait for you again to solve the other one. So the remainders of the divisions of integer a by 8 and 7 are 5 and 3 respectively, and then we are supposed to find the remainder of a by 56, yes? Okay, so when we read this question, we realize that if I divide a by 8, the remainder is 5. Okay, so I would say, let me just write very precisely, the remainder of a by 8 is 5, yes? This is the given information. So from here, what you can conclude there exists, if you want here, you can emphasize that that number is unique, Q in Z, such that what happens, A is equal to 8Q plus 5. Yes, is that understandable? So that's the mathematical translation of this English sentence. Okay, and then we also have the remainder of A by 7 is 3, yes? So this also means that there exists, if you want, you emphasize that this is unique, but you shouldn't write Q, because if you write Q, you are forcing these Q's to be the same, so you choose a letter, different letter, so let's just write Q prime in Z, such that A is equal to 7 Q prime plus 3. Yes? So these are the mathematical translations of those pieces of information provided for us in the problem. Yes? Now the point is that I want to find the remainder of the same number A, but this time I want to know its remainder by 56. Okay? So if you go to scratch paper, so let me just write here. If you want to imagine you need to have your A here, yes, because you want to divide it by 56, then you should have a 56 here, I don't know, some number capital Q, and then plus some remainder R, yes. This is your goal. So you want to write an expression of this form so that A is 56 times an integer plus an integer, but more importantly, this integer should satisfy some rule, yeah, some pattern, and that is it should be greater than or equal to 0, less than which number? 56. So this is the way that you need to think in a scratch paper. So from these two equalities, you need to find a way to reach to an equality of this form where R satisfies this condition. If you can find that relation with a given number R, which lies between 0 and 56, then you can claim this number to be the remainder. You can declare that number to be the remainder. Yes? Okay, so then you have a strategy of the problem. So you need to find this relation. Okay, what is your suggestion? One suggestion is that, okay, of course I want to make 56 here. So one way is to multiply these side by side. Of course I will get a lot of extra terms, but at least I will get 56. 8 times 7 is 56, yes? Q prime or something. Of course I get a lot of things, but the bad point would be that when I multiply these two, instead of A that I want on the left, I will have A squared. So of course this might be a strategy, but you don't really need to pursue that because it is clearly that would be a failure because of A squared, or there is a little chance for that we can find it. Okay, so it means that even though it might be a strategy, but let us forget about it. If you want to forget about this and you want to make 56 appears, what you need to do. Yes?
Can you multiply the upper one by 7 and multiply the lower one by 8, and then you take the lower one, subtract it with the upper one?
Yes. That's the only way probably left for us, yes? So let me just write here. We don't need that, I think we know this by heart, so let me just get rid of that. Okay, so as Dylan mentioned, that's another strategy that I think will work, yes? So if I multiply the first one by 7, what is the goal by multiplying by 7? Because I want to make 56 appears here, yes? So what happens is that 7a is equal to, if I multiply both sides of the first one by 7, the right-hand side becomes 56q, and then I have to multiply 5 by 7, it becomes 35. And then I will multiply the second one by 8, because still my goal is to make 56 appear here. So what happens is that 8a becomes equal to 56q prime, and then plus 8 times 3 is 24. Okay, of course I have my 56, but the bad point is that I want to have A, but I have 7a in one of them, 8a in the other one. And of course, it is not hard to see that if I subtract them, I will get exactly what I need, yes? So what from here, I can conclude that 8a minus 7a, I'm subtracting them side by side. So it becomes 56q prime plus 24 minus 7a is 56q plus 35, yes? And then 8a minus 7a is exactly the a that I need. Here I have 56q prime and minus 56q. So let me factor a 56 out. It becomes q prime minus q. Then I have 24 minus 35, which is minus 11. Yes? So more or less we are done. And if you remember something from the previous lecture, I don't think that you will face a problem. Here I cannot declare that minus 11 is the remainder, yes? Because the remainder should be a positive, non-negative number and is smaller than 56. So I can call it Q at this stage, but then I will have 56 capital Q minus 11. Minus 11 cannot be declared as a remainder. So I need to manipulate it a little bit so that I can get rid of that negative remainder. Yes? So how should I do that? Yes?
minus 56 plus 45.
Yes, exactly. So I would write it as 56. This is a skill that you need to learn. It's very, very simple. I don't think it's hard, but you need to remember it, otherwise you will face problems. So instead of minus 11, I would write minus 56 plus 45. First of all, I hope that you agree that this is exactly minus 11, so I haven't changed anything here. But the good point is that I can absorb this 56 into this 56 by factoring this out, yes? So what will happen, it becomes 56 q prime minus q minus 1, and then I will have 45. Now, this is definitely an integer, because q and q prime are integers, minus 1 is also an integer, so this combination is an integer. So let me call it 56 capital Q plus 45. Of course, I emphasize here that q belongs to the set of integers. Now, can I declare this as the remainder? Yes, because why? 45 satisfies this condition. So it means that I was able to write A in the form of 56 times an integer plus 45, and 45 enjoys these properties. So this means that the remainder is 45. Yes? Is that understandable? So I think these kinds of skills, this is very easy. You see, the algebra is very, very simple. The algebra is not complicated, but you need to learn how to think about these new problems. Okay, I think now we have a good refresher for your memory. So you see, this problem here is very close in nature to this problem, but there are some subtleties that you will face here. Because that's the same story, yes? If I give you, so that is the general question. If I give you the remainder of a number by two numbers, then I ask you what is the remainder of that number by the product. In principle, we were able to answer it for this particular numbers 8 and 7, yes? Here, I have changed the problem a little bit, and I want you to ask the problem. So you see, this problem is exactly a copy-paste of this problem. The only thing that I have changed the numbers. Okay? So this becomes a little bit more subtle than the previous one. Okay, I want to wait for you to solve these problems. Okay, I think you can do them. It's very easy. And I will remove these later, okay? Okay, so let me just again, the division algorithm and the notion of divisibility are expressed in the book, but without any exercises, more or less, at all, okay? And I told you that probably it's not a good idea if you learn something in mathematics without being really engaged with the problems, otherwise you will not learn, yes? So now you have a better understanding of what is the meaning of the quotient, what's the meaning of the remainder, and by the way, what we are following in the lessons are actually, we want to have fun with mathematics, so this is more fun than doing just very simple exercises. But as I told you before, I will not give questions like this in the exam, because I will follow exactly the book. And I just mentioned that in chapter 2, I don't know why they have talked about sequences, number sequences. This is not at all under the title of the number theory. What you see here is number theory. But the sequences, arithmetic progression, geometric progression, they are very important topics, of course. We will explore them a lot. But if you want to be honest, those are not under the title of number theory. Yes? So I will actually end up this division algorithm today, and there is one part of the number theory which will be in the exam, and that is modular arithmetic, which is the most important part of number theory, of course. And I will also give you a lot of exercises and examples related to that, and then we continue to the other sections, and then more or less you become a little bit more familiar with the structure of those things. Yes? For example, I think even in this chapter we have, I don't know, mathematical induction or something. They are not based on, these are not number theories, yes? Okay. Let us try to solve these problems together, okay? Forget about the exam, otherwise you will not learn mathematics, just care about mathematics itself. Okay, so let a be an integer such that the remainder of 7a by 17 is 12. Okay, so what is the meaning? So this means that there exists a unique q in Z such that what happens, if number 7a is divided by 17, of course I will get a quotient, which I have called it q here, but I know according to the problem the remainder is 12, and of course this is an acceptable remainder. What do I mean by that? It is non-negative and it is smaller than 17, so there is no flaw in the designing of the question at least. Okay, now we want to determine the remainder of a by 17. This is actually something I want you to learn, because this you will need in modular arithmetic, the way that you want to think in this way. Okay, so of course the crude idea is that I want to have a on the left, and the first thing comes to mind naturally is to divide by 7.
Yes.
And there is no problem with that. If you divide by 7, I will get a true equality still, but I cannot use it to interpret about the quotient and the remainder directly. So be careful. It doesn't mean that you get something wrong. You get something true again, but this is a useless true. Yes? In the context of the problem that we are working. So this is not a good idea to divide by 7. Everyone agrees with that, yes? So, yes. If I divide by 7, I can give this 7 to q, for example, keeping 17 because I need a 17 at the end. So, but q over 7, I can call it capital Q, but that capital Q is no guaranteed to be in the set of integers, yes? Okay, so what is the other alternative? We had something similar to this idea, not exactly the same thing, but we had this idea before, and I told you what to do. So for example, I realized immediately it was not hard for me because I have worked with modular arithmetic later, okay? I will multiply it by 5. Yes? But can you tell me why 5? Why 5 will work? So you see, it is a little bit indirect way of understanding the problem, yes? So it seems that I am deviating from my goal, yes? Because my goal is to have one single A instead of making it one single A. Of course, one single A, by the way, one way is, do you remember we talked about these strategies? One way is to subtract minus 6A from both sides, yes? But if I do that, what I will get, you can go to scratch paper. If I subtract 6A from here, that's good. I want to have A, I have it, yes? And then this becomes 17Q plus 12 minus 6A. Okay? Then you see that I want, what do I need in a scratch paper? What I need, I want to know the remainder of A by 17. I need something like this. Do you agree? This is my goal. In order to be able to answer the remainder of A by 17, I need to be able to write A in this form. Yes? But I don't see any way to make this in the right form unless you can find a strategy for yourself, and I will be ready to listen, of course. Is that understandable? So this natural step doesn't work. The natural step of dividing by 7 doesn't work. Okay? Do you remember I told you that sometimes you need to think indirectly, especially in number theory. Let me say, I multiply everything by 5, so it becomes 35A. And then if I multiply this by 5, it becomes 5 times 17Q. And if I multiply this by 5, it becomes 60. Yes? So why do you think this will solve my problem? Yes?
Because if you subtract 34, then you can factor it.
Yes, in 34 I have my factor of 17. So that was the whole point. So what I do, I will subtract 34A now. Yes, so what happens on the right? I will have 5 times 17 times Q plus 60, and I write minus 34. Do you remember this idea? This idea, we had it before when we were talking about divisibility, yes? That was more or less the same idea. If you go and review the exercises that I solved for you, this idea is not new for you. Shouldn't be new at least. But then what I have here is exactly the A I need. But between these two, now I can factor 17 out. And I told you, if you remember, you don't need the beautiful quotient here. Yes, you just want a quotient that you can guarantee it's an integer. So this becomes 2a plus 60. Yes or no? But can I declare this as my remainder? No, because the remainder should satisfy this condition. It's not that condition. Then I hope that you can immediately solve that problem. How should I solve this problem? Instead of 60, how can I imagine it? I want to have some number out so that it's between 0 and 17. So what can I write instead of 60? You should count the multiples of 17. 1 times 17 is 17. 2 times 17 is 34. 3 times 17 is 51. And 4 times 17 is 68, which is larger. Okay?
Yes.
So it means that I can write it as 51 plus 9. Yes? And then between 51 and 17, I can factor 17 out. Yes? So this becomes 17. 5q minus 2a plus 3, and then I have 9. Yes? And can I call this, of course I always can call it a different letter, but the point is that this different letter that I'm using for this combination is guaranteed to be an integer. Why? Because q is an integer, a is also an integer in the problem, so this combination definitely is an integer. So this becomes 17 times q plus 9. More importantly, this 9 satisfies this condition as well, yes? Yes? So this means that the answer to this question is simply 9. So the remainder is 9. Is that clear? Any questions here? Understandable? Okay. But now, I don't know, do you want me to wait a little bit? This problem is more or less a copy-paste of the first problem, unless I've changed the numbers a little bit. The solution would be a little bit different. Okay, let me just wait again for you. Now you have a little bit more experience. I hope that you can solve this problem yourself. Okay, I will give you 5 minutes. Okay, could you solve that problem? This one?
Minus 9.
No, minus 9 is not acceptable. Yes. You need to make it, if that's only problem, then you are solved more or less. You made it positive by adding some
It has to be
multiple.
positive.
So, is there any number that you got? How's that? Plus 4. Let us check. I don't know. Plus 4, is that right? Okay, what is your answer? 9. So plus 4 and 9. Let us check which one is correct. So, the remainders of the division of an integer a by 5 is 4. So it means that if I divide a by 5, it gives me a quotient, but the remainder is given to be 4. So there exists a q in z such that this. And then if I divide a by 7, it gives me probably a different quotient. And then the remainder is 2, yes? So this means that there exists, if you want, you can also emphasize that these are unique, yes? Okay, and then the problem is the same. I want to have a, the remainder of a by 35. So if you go to scratch paper, you want to have such a combination at the end. But r should be somewhere between 0 and less than the absolute value of this number. Otherwise, if you have the right combination, but the combination doesn't satisfy this relation, you cannot declare that number to be the remainder. Okay, so you need to have, this is the mindset. You need to have this in your head so that you can just go towards that. And I think you have already an experience how to do this in the first problem. So, but there is a little bit more challenging here. Why? Because here, if I multiply this by 7, the idea is the same. Yes, I want to make 35. So I multiply this by 7. So it becomes 7a is equal to what? 35q plus 28. And then I multiply this by 5. It becomes 5a is equal to 35q prime plus 10. And then, of course, what I'm supposed to do, I subtract them, yes? So if I subtract them, what will happen? It becomes 2a, and then I subtract them side by side. It's 35q minus 35q prime. So let me factor q 35 out. And then 28 minus 10 is what? Yes, I did it right, yes? Yeah, that's right. So this becomes 18. Yes? And then the problem is what? Here, I want to have a, but I have 2a. So what I'm supposed to do? I can divide by 2, okay, but that would be I don't know if that's a problem or not. Sometimes we can solve that problem. But if I divide by 2, what is the obstacle if I divide by 2? If I divide by 2, it becomes a, that's quite good. This, I can put 2 below this one. It becomes q minus q prime divided by 2. That's the problem. Because there is no guarantee that q minus q prime divided by 2 is an integer. This is not clear. Unless I can show that this is indeed an integer. If I can show that, that's okay. Yes? So, either you need to justify that q minus q prime divided by 2 turns out to be an integer, then it is okay. You divide by 2, and the answer that you get, so let me just divide. This is hypothetical. Okay, so let me just write it with a different color. If I divide by 2, I can write a, I can write 35, and then I can write q minus q prime divided by 2, then I will have 9. The only problem here that the problem is not finished is because of this part. Because I want to have a, I have it here, I want to have 35, I have it. I want to have some number between 0 and 35. 9 is between 0 and 35, so that's okay. So the only problem is that, is it guaranteed that's an integer or not? If you can justify this is an integer, this problem is done, and the remainder, I can declare it to be 9. Yes? Otherwise, I need to find another way. I don't know. Can you help me to solve the problem? Either you want to go in this way, or you have a different way to solve the problem. Which one do you want to continue? This one, to argue that q minus q prime is an integer, divided by 2 is an integer, or you want to change our strategy and solve the problem in a different way? Yes?
Change strategy.
Okay, so up to where? Continue from here, or totally forget everything?
Continue from before.
Here.
Yes.
Okay, so let me keep it, and then I will change my color right to you. Okay, so from here, you are making another strategy. Okay, so then what to do?
I chose to multiply the first one by 3 and the second one by 4.
Okay, so by 3, this one becomes 21a, and I multiply 3. Let me keep it. 3 times 35 cubed, and then multiply this by 3, which is 84, yes? And then multiply this by 4. If I multiply this by 4, because 20a, then it becomes 4. So you see, actually that is a learn what to do, yes? And then it becomes 40. That's a better strategy, yes? Why is that? Because now if I subtract these two, it becomes exactly what I need, which is a. And if I subtract these two, no problems. You don't need to get confused with these factors. What is important for me is 35. I can pull it out. So it becomes 35, and this becomes 3q minus 4q prime. And I subtract these two, it becomes 44. Understandable or not?
Yes.
Yes. So now, this 44 cannot be declared as a remainder, because 44 does not satisfy this. But you already know how to solve this problem, yes? Instead of 44, what you can write 35 plus 9. And then this 35 can be absorbed here, so then it becomes a equals to what? 35, 3q minus 4q prime plus 1 plus 9. So this is what you get at the end. Okay, can I write it like this? I can write it as A equals to 35. I can call it capital Q, and I can make sure that this capital Q is in Z, yes? And then what is left for me is 9, and 9 has the property that I need. So I can declare that 9 is the remainder. Thank you very much. So you see that you can learn. This problem, because of the changing of the number, you have to slightly deviate from your strategy in the first example. But it is doable. If you want to pay attention, you will learn. But I myself can also save the first argument. Can you? Yes? You have another strategy?
18.
What?
Multiply by 18.
Which one?
2a equals 35. From the beginning.
Here? From here?
To the right.
2a.
Yeah.
Multiply by 18.
And then minus 35.
Yes, that's a very good strategy as well. So you multiply by 18. Why 18? Yes, because if you multiply by 18, it becomes 36a. Yes? But 36a, you need only one a. So you keep it as a plus 35a. By experience, you know that this will not make a problem for you, because you move it to the right and factor it out. So that's also another strategy. It will work. Okay, let me save my strategy now. Can you justify this here? In this particular case, there is no guarantee. So this is not a general strategy. In number theory, we do not have general strategies that much. A problem from problem, you have to think again. Okay? It's a little bit different. So, do you think that in this particular problem, there is a guarantee that q minus q prime divided by 2 is an integer? Is it? So I want to mention that is q minus q prime guaranteed to be an even number? If I can show that q minus q prime is even, then definitely q minus q prime divided by 2 is an integer, and I can save this argument. And then you see that the answer will be exactly 9 again. Yes, because we know that according to Dennis's strategy, we know that the answer is 9. And I see that 9 appears here. So it seems that I can save this argument by showing that q minus q prime is even. How can I show that q minus q prime is even? When is it possible that q minus q prime is not even? This is also important. This way of thinking is the thinking that you need in number theory. When q minus q prime is not even, when q minus q prime is odd, 1 is even, 1 is odd. Yes? Otherwise, the difference would be even. Okay, but can it be possible that 1 is even, 1 is odd? Let us check. For example, q is odd. Okay? Then what happens for a? If q is odd, you multiply it by 5 becomes odd, and you add 4 to it, it becomes odd. Yes? So let me see. If q is odd, q prime is even, then I will have a problem, because q minus q prime becomes odd, and then when I divide it by 2, it is not an integer. But I want to show that this cannot happen in this case. Why? Because if q is odd, you multiply it by 5, it becomes odd. You add 4 to it, it becomes odd. Yes? But now, if q prime is even, you multiply it by 7, it becomes even. And if you add to it, it becomes even. Yes, this cannot happen. If q is odd, q prime is even, you have to admit that a is simultaneously odd and even, which cannot happen. Yes? So it means that this scenario cannot happen. Similarly, you can show that q even, q prime odd will not happen. if I consider these two cases, if I rule out these two cases, then it means that q minus q prime is even. When it is even, I am guaranteed that this is an integer. And then I can say that again 9 is the remainder. So you see that there is not one unique way to solve these problems. So here we have 3 different ways, yes? This method, and that method, yes? So this, by the way, so it doesn't matter which part of mathematics you are working in. The whole point of mathematics, because most of you will not pursue mathematics as the future career, but it doesn't mean that you are wasting your time here. You actually, if you want to be successful in your career, if your career is not a routine one and you want to be creative and innovative, if you want to have a better job, those jobs these are the demands of those higher ranked jobs. Yes? So you need to be creative and you need to be innovative to be able to win the competition with others, yes, against others. So you have to know how to solve new problems. That's the point. If you want to solve the ordinary, so if you want to solve the same problems over and over again, then of course you can get a job, but not probably a highly ranked job. So if you want to go higher and higher, you have to learn to solve new problems. Problem solving skills, you have to improve them. And it doesn't matter if you're working with number theory, if you are solving geometry problem, mathematics is the best place to learn how to think creatively. Yes? This skill you need to learn. I don't know, if you don't learn it, I don't know how many of you have seen this TV show, Good Doctor. Yes? I don't know, that's about a very smart doctor, surgeon probably, with autism problems. But if you see that problem, that is just doing some surgery or something, but they are creative. So because main problems happens there, they have seen that for the first time. And if you just want to follow the book only, even if you want to be a doctor in the future, so it doesn't mean that you don't need mathematics. The way that you want to think, you can see it in that TV series. So even though they are surgeons, most of the time they know what to do. But there are many cases that's happening for the first time, and they want to find a way. This medical one is actually very clear, because in mathematics, what happens? I cannot solve a problem. Okay, I couldn't solve. But in that case, one person will die. So if you don't know how to solve the problem, that person will die or will have severe injuries that they can carry that with themselves until the end of life. So in this case, it is a little bit exaggerated if you care about humanity. In that case, it is easier for us to think, if we do not know our job, if we are not able to solve the new problems, then we are making a really big problem for some human being. In mathematics, even if we cannot solve this, nothing will happen at the end. Yes, might be, of course. So this is why I want you to think in this way. Do not just get used to this coming to school, solve some problems for getting A in the exam, in order to be able to go to the university to do what? To repeat whatever other people have already done. It's good. I'm not saying it's bad, but at least at your age, I think you should be a little bit more stubborn to fight, you know. So otherwise you just go to the university and then start complaining there, what's the problem, I have a lot of exams, things to do. But if you really don't want to do hard work, it's better to change your life. Don't go to study at the university. If you want to go to study in the university, I think you really need to try hard to be very good in the work that you are doing. Yes. So don't think that this is in the book or not. This is the best way to learn how to think, to solve new problems. And I think you have to learn this skill, otherwise you will lose the competition for better jobs in the future. Okay, so I don't think now you have any big problems here. I want to keep these problems for you so that you can solve work on them at home. So next time, I think, yes, this week, I will start the main part of the number theory, which would be modular arithmetic, and then we continue as in the book. So I think I don't know how many of you solved these two problems. You haven't reached thinking about them? So Dimitri, did you solve them? Okay, but I want you to think. I don't want to give the answers today, but next time I will immediately solve these two problems in 10 minutes at most, and I immediately go to the next topic of the number theory, okay? Any questions? Yes?
When's the exam?
According to the book, I want to finish this chapter.
Yes.
I don't know how
There's
much.
2 chapters left in this chapter.
Sections, you mean?
Yeah, section.
Yes, what are they?
The
Number theory? No, the sequence of numbers
sequences
and
then
then...
induction.
So that's very strange. These two things are not related to number theory at all, but I will teach them and then we will have the exam.
Okay.
Yes. I remember last year when I was teaching mathematical induction, it was 5 full sessions.
5.
Yes, because that's a very important thing. But that sequences are not that much. So might be we need 7 sessions to finalize this chapter. Yes. So it would be before the new year, but probably very close to the end.
Somewhere. Oh, okay.
Okay, thank you very much.